Alright. In the previous video, we learned about the classes, the first principle of object-oriented programming. In this video, we're going to continue our discussion on the principles of object-oriented programming by starting the discussion on objects. Now, while discussing classes, we took the example of a generic TV. Now that we are talking about objects, we will now take examples of concrete TVs, like TVs of Samsung, of VU, and of Sony, right? You see, in the previous lecture, we discussed that a TV in general has the following four properties. It has a color, it has a size, it may be flat, or it may be a CRT TV. Now, for objects, the properties and the behaviors remain the same. For example, you will see that the behavior is same as that we discussed in the classes. It has the volume up, volume up, channel down, and set channel behaviors, right? But the distinguishing factor about objects is that every object has a different value for the properties. Like for example, in this case of the VU TV, the color of this TV is gray. The size is approximately 55 centimeter, I guess. So that's what I've given here. And this is a flat screen TV. Hence, the property or the attribute has the value of true, and it is not a CRT TV, hence the attribute is of false. Next, let us take another example of a TV. So this time the TV is from Samsung. Now this TV has a color of black, as you see that the bezel is black. It has a rough size of, let's say, 80 centimeter. Well, I'm estimating at this point, but it's roughly 80 centimeter perhaps. It is a flat screen TV, therefore this attribute has a value of true. And it's not a CRT TV, therefore is CRT is false. And if you look at the behavior column, you will see it has the same behavior as that of the previous TV, right? So what has changed? The values of the properties have changed. Now, to reiterate this fact, let us take an example of another TV. Okay, so at this point of time, we have taken the example of Sony TV. So the color of the Sony TV can be assumed to be white. This I feel is white, though it has a steelish white color. Size is, let's say, 24 centimeters. And it's not a flat screen TV, hence this attribute is false. But it is a CRT TV, hence this attribute is true. And it has the same behavior as any other TV. So what did you observe? For all the TVs that we have seen so far, like in this TV, Sony TV, in the Samsung TV, and in the VU TV, the properties are the same. Every TV has the color, size, is flat, and is CRT property. But for every object, the values change. If you have a look at the value column, you will see that the values change, right? So this is what makes every object unique. Though every object has the same property and the same behavior, but the values of those properties are different. This is what makes every object unique. Keep this in your mind. Moreover, we were discussing objects purely in the term of real world objects. But in case of softwares, in software terms, the state, properties, or characteristics are defined as data members. And the behavior in software terms is defined through functions, right? And the next point states the fact that I discussed just now, that because every object has different values for the properties or characteristics, therefore the objects are said to be unique entities, right? Let's move on to the definition of objects. So what does the definition say? An object is a unique entity. Why is it unique? That has been discussed just now. That contains data and functions, it contains properties and behaviors, and in software terms, these are known as data and functions, state and behavior, and together in object-oriented programming language. Now, objects are entities that are actually instances of classes. Now, what do I mean by instances of classes? Instances means, let's say, small entities, right? which have a physical existence. You see, a class can be compared, let me take a different color. So a class can be thought of as an idea and blueprint. But when you take that idea and build something up, then you build, using that idea, you build objects, right? Therefore, objects are referred to as instances of classes, meaning using that same idea, multiple objects can be created having some different values. This is what I mean by instances of classes which has a real existence. You see, a class or a blueprint is just a piece of paper, it's just an idea. But when you give that idea some form, such as in software terms, when you create an object, the object has a real existence. The class does not reside in the memory of your computer. It does reside in your hardware, in your hard disk, but it does not reside in the RAM of your computer. When your program runs, the entities that exists in your memory or your RAM are objects and not classes, right? So that fact has been reiterated in the last statement. In software terms, an object exists in the memory, whereas a class will not. I hope you have understood the difference between classes and objects. In the next video, I'm going to state the differences in a formal manner, and I'm going to continue with the discussion on the rest of the principles of object-oriented programming. All right, see you in the next video. Bye for now.